Hello learners, this is Habeeba with Excelwithme. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is research methodology paper, under that topic correlation of techniques with the subtopic Karl Pearson's product moment correlation coefficient, that is denoted with small r. Let's start with correlation of techniques. Correlation is a statistical technique that can show whether and how strongly pairs of variables are related. When we take any research issue, we are going to test some variables. That means because of this correlation, we will understand the relation between certain variables which we are going to test. For example, height and weight are related. Taller people tend to be heavier than shorter people. The relationship isn't perfect. So to understand about these relationships, we use this correlation of techniques. Now what is correlation? Especially it is an analysis of the covariation between two or more variables when the relationship between the two variables is quantitative. The statistical tool for measuring the relationship and expressing it in a brief formula is known as correlation. If a change in one variable results in a corresponding change in the other, the two variables are correlated. Let me tell you one example here how we do this correlation analysis. Suppose I am taking the students of maybe 8th class. If there is any impact of English subject on any other subject, mathematics, maybe social studies, then I will take both whichever subject's marks, then I will do the statistical treatment, then I will understand the relationship, whether there is any relationship is there of on the studying of English, any impact is there on the other subject. So I am testing the two subjects of the students, finding out the relationship between, if any, existing. If the change in one variable appears to be accompanied by a change in the other variable, the two variables are said to be correlated, and this interdependence is called correlation. If there is any relation, if the students are studying English, if they are good in English and they are solving mathematical problems also, that means there is a relation, correlation is there between the studying of the two subjects. There is an impact of studying of English with relation to mathematics, we can say. Now correlation indicates relationship between two or more variables. This correlation can be interpreted in terms of direction and magnitude. Thus a relationship between given two variables can be positive, negative, or there could be no correlation. Further, the correlation may range between +1 to -1. Sometimes there will be relation, sometimes there will be no relation, maybe sometimes positive, sometimes negative, or there could be no relation. Three situations can arise when we do the analysis. Now, what are the types of correlation? In a bivariate distribution, the correlation may be 1 positive, negative, or 0, and the second one linear or curvilinear, that is non-linear. So these are the two types of correlation. Now what is coefficient of correlation? To measure the degree of association or relationship between two variables quantitatively, an index of relationship is used and is termed as coefficient of correlation. Now coefficient of correlation is a single number that tells us to what extent the two variables are related and to what extent the variations in one variable changes with the variations in the other. Now symbol of coefficient correlation, let's understand here. The coefficient of correlation is always symbolized either by small r or p or rho, rho. The notion small r is known as product moment correlation, and then coefficient of Karl Pearson's coefficient of correlation. Now the symbol P, that is rho, is known as rank difference correlation coefficient of Spearman's rank correlation coefficient. We will understand clearly about the second one in the next class. Today we are going to focus with the first one, that is product moment Karl Pearson's coefficient of correlation. Now let's understand the two here. Positive, negative and zero correlation, when the increase in one variable, that is x, is followed by a corresponding increase in the other variable y, the correlation is said to be positive correlation. Now the positive correlations range from 0 to +1. The upper limit, that is +1, is the perfect positive coefficient of correlation. The perfect positive correlation specifies that for every unit increase in one variable, there is proportional increase in the other. For example, heat and temperature have a perfect positive correlation. If on the other hand, the increase in one variable x results in a corresponding decrease in the other variable y, the correlation is said to be negative correlation. The negative correlation ranges from 0 to -1. The lower limit giving the perfect negative correlation, the perfect negative correlation indicates that for every unit increase in one variable, there is proportional unit decrease in the other. Now let's see the zero correlation. That means no relationship between the two variables x and y. The change in one variable x is not associated with the change in the other variable y. For example, body weight and intelligence. That means there is no relation. If body weight is high or low, what does it matter with the intelligence? That means no relation. And shoe size and monthly salary, obviously no relation here. Now the zero correlation is the midpoint of the range, that is -1 to +1. Here you can see the picture here with the relationship, that is perfect negative correlation here given in the left side. Here this is perfect negative correlation, that is -1, and this is no relation in between 0. Now this one right side inclining, that is positive correlation, that is +1. Now Karl Pearson's product moment, quickly let's understand. This is correlation coefficient R. Pearson's product moment correlation is one of the methods to compute coefficient of correlation. This is mainly used when the assumptions of parametric statistics are met. This method is named after Karl Pearson, obviously, who invented this method. It is denoted by R. Now what are the assumptions? Let's understand before solving the coefficient of correlation, any problem. Assumptions. What are the assumptions related to Pearson's product correlation? Number one, the variables used to compute R are continuous in nature and the scales of measurement are interval and ratio. Now the second one, the distribution of the variables in this method is unimodal, that is single, that is unimodal, and it is close to symmetrical. The distribution need not be normal here. Maybe this side skewness we understood, no, maybe it can go this side or that side, positive or negative. The pairs of scores involved are independent in nature and are in no way connected with other. There is a linear relationship between the two variables. A scattergram thus drawn with the help of scores in the two variables will denote a straight line. Now R is mainly used to ascertain the sign and size of the correlation that can be positive, negative or zero correlation and will range between -1 to +1. Now what are the uses of Pearson's product moment correlation? Let's quickly understand. It helps in determining the relationship between two variables quantitatively. With quantification, it is possible for us to compare. That is, we need some data, numerical data quantitatively, then only we can treat those variables. Now based on R, regression equation can be computed. Thus after computing R, it is possible to compute regression and determine whether one variable can be predicted based on another variable. R can be used in computation of reliability and validity, very important these two, of psychological tests. It will also assist in computation of factor analysis. Now let's understand the computation of Pearson's product moment correlation. There are two methods here. The first one, that is the formula for the first method, is given here below. You can check it out. You can pause and understand the formula thoroughly. Where R correlation X, deviation of any score of X from the, I will not read out all those. You just pause and please note down the formula, and also what does these denote you can mention. So the formula can be simplified as follows here given. Thus, by substituting the values of standardization also, you can obtain with this formula the calculation. Let us understand this method and steps involved in it with the help of an example here. A researcher wanted to study the relationship between data 1, that is X, and data 2, that is Y. The data below here, you can check it out. The computation of coefficient of correlation. First, number 1 is participants, then data 1 is X, data 2 is Y. Then we will understand all this doing the formula. You can pause and please do the sum here. So first step is the scores under X and Y are totaled separately. Thus sigma X and sigma Y is obtained, as can be seen above in the second and third columns. You have seen here, second and third columns here totaled here. Then comes N is also noted, and in this case it is 10. You can see here N is 10 here given already. You can pause and please check it out the table and solve the sum. Step 2, mean is now computed for the data 1, that is X, and data 2, that is Y, as follows. Mean for scores on X 3, mean for scores on Y, that is 4. Now step 3, in the third step, deviation is computed for each score of X from its mean, that is 3 in the case of this example. In a similar manner, deviation is computed for each score of Y from its mean, that is 4. These are entered in the column 4 and 5 above under headings X and Y respectively. Now the fourth step, the values thus entered under X and Y are multiplied and entered in column 6, and then they are also squared and entered under column 7 and 8 with headings X square and Y square. Further, the scores under each of these columns are totaled to obtain sigma XY, sigma X square, and sigma Y square. So step 5, using the formula we can compute here. Answer will be 0.89. Thus the coefficient of correlation obtained for the above data is 0.89, denoting that there is a positive and high relationship between the two data sets X and Y. Already we understood 0 to plus 1 we calculated as positive. So here 0.89 is positive relationship. Now let's see the method 2. The formula is given here. You can pause and please note down the formula, and also what does these denote you can understand easily. In this method, the deviations from the mean are not computed. Instead, raw scores are used to compute R. Let us understand this method and steps involved in it with the help of an example used earlier for calculating R. You can pause here, note down the table, then you will understand easily the data here. Step 1, total scores for X and Y in column 2 and 3 are computed and denoted as sigma X and sigma Y. In the case of present example, they are obtained as 30 and 40. If you see here, 30 and 40. This one, 30 and 40. Then step 2, in column 4, XY is computed where the paired values under X and Y are multiplied. Thus for participant 1, X value 3 and Y value 4 are multiplied and 12 is obtained here. Similarly, XY is computed for all the participants, and then sigma XY is also computed. Step 3, in column 5 and 6, x square and y square are computed. These are squared values of x and y respectively. Further, sigma x square and sigma y square are computed, that are assumptions of x square and y square respectively. Now step 4, use the formula to compute. You can mute here and also write down the formula. You can solve this here, thus same answer must come, because the step 1, that is the method 1 and method 2, thus R obtained is 0.89, denoting a positive and high correlationship. Thank you for watching. If you like the video, please do like, share, subscribe and comment below. Thanks for your attention and time. Happy learning.